Welcome and thank you for attending my presentation today. The title of my session is Embracing Database DevOps through CI/CD. Remember to check all the things that PASS has to offer. There are great online resources like PASS Marathon, virtual groups, and really cool initiatives as SQL Saturdays and local groups. My name is Robles. I am originally from Guatemala, living in the United States for the past 3 years. I have 10 years of experience working in the database administration field as primary consultant, DBA manager, and now as a solution architect working for large-based US companies in various industries. I have the honor to be a Microsoft Data Platform MVP and a friend of Redgate as well. Speaking about my community work, I am the leader of the Guatemalan SQL Server using group. And finally, I represent my blog/consultant company called DBA Master. Here's my contact information in case you guys want to connect or send me messages on Twitter or simply to follow me on GitHub. Okay, that's enough about me. Let's focus in the agenda for now. I will have about 60 minutes to talk about Database DevOps today, specifically adopting techniques to help you integrating your database and application deployments into a single CI/CD pipeline. Our first topic today is DevOps, a brief definition of what it is and what are benefits and practices of this methodology. Then I will start on focusing in today's topic, Database DevOps. As mentioned in the session abstract, Evolutionary Database Design is the best phrase to describe database migrations. And the best way to put this in practice is through Flyway migrations. I will give you an introduction of what Flyway is and how it works. And finally, I will share some examples on how to get you started with Database DevOps to create and manage an integrated pipeline. Lots of fun today. I hope you guys like it. DevOps. So, what is DevOps? I am sure that the very first thing that will come to your mind is this picture. This infinite loop that includes all the steps of DevOps. But let me tell you this. DevOps is more than that. DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. I know there are lots of definitions of DevOps available in the web, but I think this one from Donovan Brown from Microsoft is really good. So I just wanted to include that definition on this slide. Alright, so what are the benefits of DevOps? There are many. But I would say the most important is that it allows us to deliver software projects quick and reliable, at the same time keeping a great customer experience. This enables organizations to better serve their customers and compete more effectively in the market. Of course, we want those benefits, right? But how we can achieve them? That will be through the practices. This is a big list, and due to time limitation, I won't have time to go through each one of them, but I will focus mainly in this group today. The first one is infrastructure as code. In this practice, we provision and manage our infrastructure using code and software development techniques. Then we have continuous integration. It's a software development practice where developers regularly merge their code changes into a central repository, after which automated builds and tests are run. Continuous delivery. This is the ability to get changes of all types, including new feature, configuration changes, and bug fixes into production. Finally, microservices. This is an architectural style that structures an application as a collection of services that are highly maintainable and testable. Let's move on to the next topic, DevOps for the database. In case you haven't already, I recommend you checking Redgate's 2020 State of Database DevOps. This is a very complete resource that provides insightful information on how organizations are implementing database DevOps practices. There was a couple of questions on this analysis that really caught my attention. The first one refers to the greatest drawback in traditional database development. Not a surprise that most organizations are still experiencing slow development and release cycles. I can't confirm that myself because that's an actual problem that I notice in many organizations that I work for. Let's move on to the next question. What is the greatest challenge in integrating database changes into a DevOps process? As we can see, the major challenge here is synchronizing all our application and database changes. So, what is happening here? What do you think is the problem? Well, I will provide you the answers to that question. But for now, let's think about those two observations again. And the very first thing that comes to my mind is that any database deployment is really slow, right? Alright, so let's take a look at this developer story. Most of us know what is the exact version of our application currently in production, correct? But if I ask you, from the application and version control perspective, what is the exact version of your database schemas? You will probably say, I don't know. Is that correct? But if we stop to think this for a moment, we will realize that this problem was already solved at application level, right? But the question is how? Well, the answer is simple. Most of the development teams, they uses version control tools like Git or GitHub to maintain control and versioning of their code. Let's move on forward in this scenario. Updating a database schema is quite simple when there is only one developer working on our application. Here we have the example of Axel working on his own machine on ShinySoft, and it has a copy of ShinyDB. And the same goes for Christian here. He has a copy of ShinySoft and a copy of ShinyDB. They can work in this isolated environment, but these will reach new levels of complexity when they start consolidating all the changes into an integration server. And this problem will be the same for the test environment and also for production. So once again, we have a problem here, right? So let's talk about Evolutionary Database Design. Evolutionary Database Design is the title of an article you can find on martinfowler.com. This is a very large and interesting topic, but due to our time limitation, I will have to do my best to provide you a summary. So here you have some key characteristics of this practice. The first one talks about DBA and developer collaboration. The DevOps culture demands people with different skills and backgrounds to collaborate closely. For most changes, it's up to the developer to call on a DBA if they are concerned about the database impact of the changes they are making. A DBA can also take the initiative here if they notice that a change will have a significant impact in the performance of the application, or in this case the database. They can seek out the developer and get involved in talks to address these problems. Version control, no-brainer here. Everybody benefits from using version control. And I'm talking about all artifacts like application code, unit and functional tests, and other code such as the one we use to build our environment. All changes are migrations. Any change applied to a development environment should be captured and consider this change file as a first-class artifact that can be tested and deployed to any of our environments, following exactly the same process we do for application code changes. Everybody gets their own database instance. People learn by trying things out. In programming terms, developers like to experiment with certain feature and make a few attempts before picking one. They can work in this private copy of the database without affecting others. Continuous integration. CI involves setting an integration server that will automatically build and test the main software branch. A rule of thumb is that each developer should integrate into a development pipeline at least once a day. And there are many tools that can help us to achieve this. We have something like Jenkins, Travis CI, GitLab, GitHub Actions, and Azure DevOps. All these characteristics sound really attractive, but how do we put them in practice? This sounds like that unicorn that it's impossible to reach and see. But no, there is a way we can approach this, and this is through database migrations. We can define a database migration as a set of SQL commands that are part of a story. Each migration needs a unique identifier, something like a special format we can use to identify the action that will take place as part of that migration. We need to keep track of new and future migrations that will be applied to our database. Something like a history table will be great because it will serve as an audit log. We need to manage certain sequence, have the capability of creating a baselines for an existing project, or maybe we can start from the scratch applying all those migrations without jumping through the hoops. Finally, we need to manage the database consistency by sequencing the correct order of the changes between the migrations. For example, we should apply an alter table before inserting new data, otherwise this migration will fail. Okay, so next topic is Flyway. What is Flyway? It is an open source tool that allows us to perform database migrations simply and quickly. It was designed to facilitate continuous integration processes for any database on any platform. Database migrations can be applied using the command line interface, using the API for Java, using SQL scripts as well. Flyway is capable to track the actual and future version of your database, creating a table called schema version. It would save all metadata about our migrations performed so far in that table. Let's have a look at Flyway's folder structure. As we can see, this is quite simple, right? And I would say the most important folder here is the conf, because it will store our configuration file that we will use to put all our settings to connect to our database. Then we have SQL folder where we'll be storing all our SQL migrations. And in case you want to use Java-based migrations, you will have to use the jars folder. Alright, so Flyway has basically 7 commands. And the names of each command is quite intuitive. Migrate, it would simply migrate the schema to a latest version. Clean is very useful for development and test, and because it will give you a fresh start. It will wipe out all existing database objects like tables, views, store procedures, and anything else. Info, it simply prints the details and the status of the information of all your migrations. Validate, it helps you to verify that the migrations applied to the database match the ones available in your local file system. Baseline, this is a great way to introduce Flyway to an existing database by baselining them at a specific version. Repair, this tool fixes problems with the schema history table, like removing failed migration entries. Undo, it simply undoes the most recently applied version migration. Configuration file. Flyway supports loading configuration by config files. These settings are simply key value pairs. I put some examples here on this slide. As you can see, the first one is the URL, and this is pretty much the connection string where you will be defining the database type or DVMS type you want to connect, the host name, and the port. Then the usual stuff as user password. We have to find these in order to connect any database. And finally, Flyway supports environment variables in config files, and these values are like placeholders that can be substituted. So here's an example. Okay, so SQL migrations. Migrations are most commonly written in SQL. That makes it really easy for us to get started using any existing scripts, tools, and the skills that we already have. You can use SQL-based migrations for any database change, like DDL changes to create and drop objects, or also to make data corrections. We have three types of migrations, and for these migrations to be picked up by Flyway, we need to comply with certain pattern. Let's take a look. The first is the prefix. As you can see, we have a V for versioned migrations, we have a U for undo migrations, and an R for repeatable migrations. Then we have the version, and this is the number we want to assign to our SQL-based migrations. Repeatable migrations does not have a number, and that makes sense because this is a migration that will run every time. So you want to use it to, for example, create a view, because we want that view to have the latest structure of our table, so it makes sense to put something like that as a part of a repeatable migration. Then we have a separator. In this case, it's 2 underscores. Description. This is the information we will see stored in the migration history table. And finally, the suffix. In this case, is the file extension. It is quite obvious that it's gonna be .sql because we're working with SQL migrations here. Okay, so how it works. Let's take a look at another visual example. The first thing we have here is Shiny Stuff again, and we have Flyway here, and we have ShinyDB, but it's empty at this point. We have a couple of migrations here. So the first thing that Flyway will do is check if the history table exists or not, and if it doesn't exist, it is going to create it. And at this point, it's empty. We don't have any metadata right now. Then Flyway will apply the version 1, migrating all those scripts and deploying the database changes into my target database. And then Flyway is going to perform the same for the second version. As you can see here, we have a difference between the colors because these 3 blue tables were created as part of the first migration, and these 2 brown tables were created as part of the second migration. Alright, so let's have the first demo of today, and this is about using Flyway migrations with containers. Alright, let's have our first demo of today. This is about getting started with Flyway migrations using Docker. Here are all the steps that I'm going to be performing. And the first one is to create a SQL Server container. Then I will create a new database called eBikes, and it's going to be initialized for my purposes. We will take a look at the Flyway migrations folder structure, then all related files that will make part of my migrations that will be executed through Docker containers. And finally, I will make sure all these changes were successfully applied to my database. Okay. All right. So the first thing is about creating my SQL Server container, and it's done. This is a new SQL Server instance called eBikes. I am going to use a local volume to make sure my data files are persistent. I am mapping the port 1400 that is kind of listening through that port in my computer, and it is mapped to the 1433 that is the default listening port for SQL Server within the container. Then I am saying, okay, I want to use SQL 2019 CU8 Ubuntu 1804 image, and this is something I included as an additional parameter. I want to make sure I'm using my resources wisely because I have Kubernetes local implementation running on my computer called microarcades. I just want to make sure I don't run out of resources. So this is kind of a best practice you can adopt to make sure your containers are not running free and using as much memory they can. And by the way, the CPU quota is given by the configuration I have in place to my Docker implementation of in this computer. Okay. All right. So let's run this query. Make sure I can connect to a port 1400, and yes, the eBikes instance is there available for me. Okay. As you can see, this is something I did here. A little trick. I am not writing or passing the SA password parameter over and over again. I'm using this little trick to set the SA password as a environment variable for SQL command. Okay, let's take a look at the file that I am going to use for my database unit. This is quite simple. This file is this script is going to create a new database called eBikes. It is going to create a new login for Flyway, and this login will have certain server levels per roles. It is going to be able of creating databases. It can create users. It can modify users logins. Excuse me. And finally, I am granting some database level permissions to these to Flyway's user in the eBikes database to make sure it can create, it can drop, or it can alter any object. Okay. All right. So let's run this script to initialize my database, and it's done. As you can see, I get like a little nice input of what was executed against this instance, and this was because I'm using the E parameter. That means echo, and it returns all inputs from the script to my screen. That's really nice. All right, so I should have a new database called eBikes now. Let's make sure run this query, and yeah, I have a eBikes database living on my eBikes SQL Server instance. Just to prove that I'm not cheating, let me run this query to list all tables and objects in my eBikes database. As you can see, it's empty, so no objects at this point. Okay, great. Let's clear the screen and let's take a look at this. Remember, I said that we have to explore the folder structure. Okay, the main thing I am going to be doing here is using a local config file that will be mapped into Flyway's configuration for containers and as well my scripts. So let's take a look at the configuration file first. This configuration file is quite simple. Let me zoom in a little bit for you. Okay, so remember from the slides that says the Flyway uses a key value pairs for defining the settings on my configuration file. So this is pretty much is happening here. I am saying, okay, I'm using SQL Server in my local host, listening through the port 1400 for the database name called eBikes. I'm going to connect using the user called Flyway with this password, and my default schema, this is important here, is gonna be DVO, and this is gonna be for the migration history table. And then I am saying, okay, Flyway should have access to the schemas DVO, production, and sales. And this is because my database has multiple schemas, so I want to make sure Flyway understands what are the schemas where I'm going to be deploying objects. Okay, let's take a look at those scripts. And before doing that, actually, I want to show you something. I found this nice extension of Visual Studio Code where you can define your entities using JSON, and then it is going to produce this little nice ER diagram. How cool is that? This is pretty much my database in a nutshell. As you can see, I have nine tables. Excuse me. I have the brands, orders, products, and the usual stuff for a shop. So this is nice in case you want to use it. You can even import an existing SQL DDL, and it will produce the ER diagram for you. I find it really handy for this purpose when developing stuff locally. Okay, so let's take a look at the scripts. All right, so there are quite a few scripts here, and these scripts are here. I will take a look at just a couple here because there are too much. Okay, what I am doing here. All right, actually, let me open it from here. Okay, so this script is about creating some tables. As you can see, I am defining the name of the schema here, and it's creating the tables for categories, brands, and products under the production schema. And I have sales related tables here because those tables belongs to the sales schema, and orders here, and so on. But this is just the structure, right? As you can see, I'm saying, okay, the version 1 of my database is just about structures. Version 2 is about loading data into those structures. So let's take a look at those nice scripts. And by the way, just for copyright, this is a database that was taken from SQL Server tutorial. I find it really great for this example, so I grab it and I just put some little sauce here, put some comments and some stuff. All right, these scripts are really large, and as you can see, it is going to insert lots of data here, lots of data. So this is cool because we can use Flyway to create objects and also insert data into our database. We can even perform updates, deletes, everything. It's a normal SQL script that will be executed through Flyway. Okay. Remember, here's the folder structure of Flyway that I mentioned this on the slides, and this is the most important thing. Here's how the container volumes should look for Flyway. So I can create a volume for the configuration file, I can create a volume for the SQL, I can create a volume for drivers and one for jars, and the path that I have to use to map my volume to Flyway's container volume is this. So if I want to, let's say, copy and paste my configuration file from my computer to Flyway's container, I must do a mapping between this volume and this path within the container. Okay, let's take a look at that. I'm using a couple of variables here to make sure I am not writing down the path over and over again, but as you can see, I have one variable for my config file and one variable for my scripts, and this is just, as I said, the path where these scripts and these files are living, and this is pretty much here, my computer. Okay, like a shortcut, if you will. So the first thing I'm gonna do here, it is execute a Flyway info just to create the history schema table and also to find out what is going to happen when I execute the migrate command. As you can see, I'm doing the mapping between my config file, my computer, and Flyway's file system here, and the same goes for the scripts. So let's execute this, and here we go. It was successfully. Flyway is saying, okay, I am going to create these migrations from the 1.1 to the 2.3, and the current status is pending because this migration has not been executed yet. So let's go ahead and migrate everything, and it's almost done. As you can see, I got this little nice input of what's going on, and it's done. All my 6 migrations were applied successfully in a matter of 5 seconds. I got all my instructions created, all my data was loaded into these tables. And let's execute the info command here just to make sure all information was stored in my history schema table. As you can see, the status has changed from pending. Before it was pending, and now it is success, and it gives me some information when it was installed and the type of a script that was executed for each one of those migrations. Cool. All right, this is good. It looks really good. But what about if we want to run a query? Here is an example. If you want to get the same information using queries, here's the example if you can do it and follow along. But the final step is to make sure all those changes were applied successfully to my database. So let's connect to my database, but this time let's use Azure Data Studio. Just let me find my e-bikes local database. It's here, and let's take a look at e-bikes. Let's take a look at the databases here, the tables here. As you can see, I have a lot of tables, production brands, and obviously order items should have more data. So let's run a select here really quick, and yes, I have my data. So that proves that all my migrations were successfully completed. I have the Flyway schema history table here, so you can see if I run a query, I got more information about let me close this down, who installed this migration, when it was installed. So lots of cool stuff here. Okay, all right, so let me go back to my script, and I guess this is all for this demo. Let's go back to the presentation and continue with the next topic. All right, getting back to the presentation, our next topic is our final topic, integrated pipeline. Databases and applications should coexist in the same deployment pipeline. That means that they should share a single development cycle. Database development should not be handled different from application development. Remember, I already mentioned some of the benefits and some of the practices of DevOps, and here is where we are going to put everything in practice. Okay, first one is source control, second was continuous integration, and finally continuous delivery. And the whole concept of an integrated pipeline is where we will be creating a single stream that will include our changes of our database through database migrations and application changes. And this is going to follow exactly the same process of build, test, and deploy. Okay? And Azure DevOps is a tool we can use for such purpose. But what is Azure DevOps? It is a Microsoft product that provides version control, reporting, requirement management, automated builds, and so on. But today, I'll be mainly focusing on Azure pipelines. These Azure DevOps components allow us to build, test, and deploy with CI/CD that works with any language on any platform. It is free for open source projects. It is really extensible. It works really well with containers and Kubernetes and has YAML support. Alright, speaking about Kubernetes, what is Kubernetes? Well, that will be quite impossible for me to summarize in a single slide, but at least I just want to put some key characteristics here in this slide. And the definition of Kubernetes is that it is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So, as I said, it is a combination of these characteristics, but also allows me to create loosely coupled applications. These applications can be broken into smaller, independent pieces and can be deployed and managed dynamically. This is not a monolithic stack running on that big single-purpose machine anymore. Alright, so let's put everything on practice right now with this demo about an integrated pipeline. Alright, let's get into our second demo. This is going to be really interesting. This is where we are going to apply the integrated pipeline that I mentioned. So there's a lot of steps here. In case you have any question about this, please feel free to ping me in whatever channel you might like. Okay? But for now, I will give you a quick summary of what we are going to do. we're going to take a look at the repository structure. I will show you my Kubernetes architecture. We'll connect to my SQL Server instance running on Kubernetes, which is an empty shell database. We'll review the Docker images that I'm going to use for the Flyway migrations, for the application, and we will take a look at the Azure Pipeline. We will push some changes, monitor this pipeline. I will show you how the migration occurred for this architecture, because it's a little bit different. We'll check the status of the job. I'm going to create a job in Kubernetes. We'll take a look at the application and make sure everything is okay. All right. If you want to take a look, here is the repository of this application. This is a solution made for kids to learn about geography by learning. Okay. Just let me run this just to make sure I have these environment variables loaded in my configuration. Awesome. And I am ready on this path. Okay. So the first thing is about checking the repository structure. This is quite interesting because, as you can see, I'm synchronizing my database changes with my application changes. How cool is that? And my database changes are going to be taken care by migrations. So I'm including all scripts here on my SQL scripts folder, and every single change I want to apply to my database will be part of this folder. I have an image here, Docker file. I will show you that in details later. And as well for the application. As you can see, this is an MVC solution using .NET Core. And also I have an additional folder for my manifest files. Here is one for the web app, one for SQL Server, and one for my migration job. The one for SQL Server, and it is just in case I want to perform any upgrades to my SQL Server, because this is pretty much static. I will show you why. Okay. I already connected to my Kubernetes cluster, but let's make sure. GeoKids is the name of my cluster. I have two nodes, node 0 and node 1. Both are running on 1.18 version of Kubernetes, and I have a deployment here. My deployment, it is just my SQL Server instance. As you can see, only one, it's ready. We can take a look at this deployment, but it's quite standard, I would say. It's a 2019 CU8 Ubuntu 18.04. Of course, it's SQL Server. As I said, it has only one empty shell database. My SA password is obfuscated, or is stored in a Kubernetes secret. So pretty much standard. Here is the manifest file in case you want to check. This is, as I said, pretty much standard at this point. Let's take a look at this. This will be important in the next part. Just let me click this. There we go. All right, so here is this command. It is returning me the name of my pod, the status, and the node. As you can see, SQL Server is running on the node 1 of my cluster. Okay, I have a couple of services. The service that I have created previously for this Kubernetes cluster is one for my web and one for my database. There is two different things here. My database is using node port. That means that there is no external connectivity outside the Kubernetes cluster. And my web app will have connectivity through the internet. So I have a public IP that I can reach from my computer, but I cannot connect to my SQL Server instance from the internet. And this is for security purposes. Of course, I have full access, but in the real, I would say in a real implementation, you want to keep limited the people that will have access to this SQL Server instance. You'll be asking yourself, how can I connect if I don't have a way to reach the server from the internet? Well, worry no more. I found a really creative way we can do it. I created an image of SQL command. This image, it is like a SQL tool utility I can use on any container. So what I'm going to do, I am going to create, let me go here. I am going to create a SQL command container that will help me to run queries and connect to my SQL Server running on Kubernetes. In case you want to take a look, here's the repository on GitHub. Okay. All right. So let's go back here. So I'm going to create a container within my Kubernetes cluster called SQL command pod. It is going to be removed after an execution. It is not going to restart in case there is any issue, any error. It's not going to try to restart this pod or this container, if you will. And here's something really interesting here. I am selecting on which node I want this pod to run. And if you notice and you remember, my SQL Server instance is running on the node 01, and this is going to run on the 0. And this is because I want to be very careful about my resources. I don't want to waste resources. And then I'm using my image here, the one I show you on GitHub. And take a look at this. I am saying, all right, use the service for my database on the port 1401 and use the user Flyway. And here's the password. This password obviously is a variable that I have on my local environment. And then it is going to run a query just to get the list of databases living on this server. Okay, let's run this query. And there we go. So I have the list of databases. I have GeoKits already. There, it's an empty shell database, and the pod was deleted after I executed this query. Okay, great. What about if I want to do, or I want to execute more complex queries using SQL command? For example, I want to get the list of tables and schemas. So I am going to execute this query, and I'm doing a little trick here. As you can see, the format is really good, and it's because I'm doing a conversion of this column to a bar chart, and that gives me this little nice output. A lot of people says that you cannot format the output of SQL command, but that's not true. All right, so I can use another way to connect, and this is using a redirection. So let me do a redirection of the port 1402 to my local computer from this Kubernetes cluster. Okay, so I'm going to grab the name of the pod and I'm going to do some forward, and right now my computer is listening to my SQL Server instance on the port 1402. Let's go back to this session and run a query again. And I am using the little trick I did before. I don't want to write down the password and user all over again. And let's run this query as I were connected to my local machine. Let's run this query. And there we go. This query is returning me the logins that exist on my SQL Server instance. And I run this query because I want to show you that Flyway has a SQL login already created on this instance. This is really cool. This is just another way you can connect to a SQL Server instance that doesn't have a public IP. Okay, let's do something different now. All right, let's take a look at the Flyway migration image. The Flyway migration image, it is pretty much what I did in the previous demo. I am going to copy some scripts from my SQL scripts folder that is here, my computer. Let me show you. There we are, my scripts, and I have a Docker file, of course. Okay, I am not going to go through details of showing you each one of these scripts, but I am pretty much creating a continents, regions, and countries table. The first migration, it is going to create the structure. The second migration is going to create the constraints, and the third migration is going to load the table data. Okay, this is really cool because I will use some API objects from Kubernetes to I would say like map configuration files that you usually use in a server, but I'm using this object called config maps. So I created a config map to load my configuration file for Flyway. So let's describe this object so you will understand a little bit better what I'm talking about. Let me clear here and run it again, and here we go. So this config map object has a flyway.com file, and this file has the configuration for my migrations. So here is the connection string. As you can see, my host name is my service name within my Kubernetes cluster, my database, and my user. I don't have a password here, and I did that in purpose because I don't want to expose that password. So I'm using secrets. I'm using secrets to hold the password of my Flyway user, and also I did it for my as a user for SQL Server. So you can check the password here if you want, and here is the JSON output. Obviously it is encrypted here, but this is just a little nice way to see it. Okay, let's focus on the Docker files for now. Okay, we have two Docker files, as I said. The first one is for my migrations. This is pretty much what I did before. I'm reusing one of the existing images of Flyway, and then I'm just simply copying my scripts to this location within this container. That's it. I also have a folder called manifest, and this is quite interesting because, as I said at the beginning of this demo, I have my SQL Server deployment there, my web deployment, and my migration. Let's take a look at the web deployment first. This deployment, as I said, it is traditional .NET application, but I'm using something special here. Remember I mentioned that we can use config files to load configuration of our application. Well, I'm leveraging one of the config maps that I created for my application to use or map environment variables that were defined on the definition of this image. My migration is special as well. I have a lot of best practices here. I am using some variables to replace this placeholder with the actual value from my pipeline. But take a look at this. I'm saying, okay, use this image. This is my customized image for Flyway. And I'm saying, okay, Kubernetes, please create this job. This is a one-time only task that is going to migrate whatever is part of this migration, and as well will return the input of what was done. As well, I am using environment variables again to hold the values from my configuration files, and I am doing it for my password. But take a look at this. I am doing something different for the configuration. Remember the configuration file that I showed you like a minute ago? I am going to mount that actual file, that config map from Kubernetes, into this file system within this job, because it has the configuration I need. And this is the best practice, because you don't want to be changing this over and over again. It will be there in just one place. In case you want to make an update to that file, you just need to go to the config map within Kubernetes, make the changes, and that's it. All your migrations will take that, because I am leveraging that object. As you can see, I'm saying, okay, I'm mounting this volume, config volume, but this config volume is mapped to this config map within Kubernetes. And here is the last part where I'm saying, okay, in case there is any trouble, please try again. And that's it. Okay, let's go back here. Let's take a look at the pipeline. Okay, this is a YAML Azure pipeline. I have certain variables here. The first one is my Docker organization. I have a couple repositories, one for my web app and one for my Flyway's migration. Then I am using a variable to control the version of my web app and my database version. Remember those placeholders that I showed you from the YAML files? These are the values that are going to replace those key placeholders there. Okay, I have a build stage where I will be building the image for my web app, as well pushing the latest version of that image into my repository, and everything is using variables. Okay, the same goes for my Flyway migration. I am building my Flyway migration here, and then I am pushing my latest image into my Docker Hub repository. Here is some placeholders for some tests. Okay, so artifacts, and this is quite important because remember those manifest files that I will be using on this pipeline. So I want any change that I made to this manifest to be copied and then published into my staging directory within my pipeline. That means that all my manifest or all my YAML files from my GitHub repository are going to be copied and published into my pipeline for my pipeline to use those files. And why? Because during the release stage, I am going to download those files. So I'm going to grab the latest version of those files into my pipeline, and then guess what? I'm going to replace those placeholders, and I'm going to replace everything within the manifest folder that is a YAML file, and it is going to replace the values or anything that I put in the YAML file to be replaced with the actual numbers or the pipeline build number in this case. Okay, and finally, the Kubernetes deployment. I am doing the deployment of my web app here. I'm using, as you can see, the manifest for my web app. Then I am just getting the pods. I just want to make sure my pods are created successfully, and then creating the job. The migration job is going to be created in this part, and finally I am retrieving the list of jobs in Kubernetes. Okay, so let's commit the changes here. Let me add the changes. Let's say, all right, base version 1.0 for the GeoKids database and web app. There we go, and git push. Okay. All right, so let's jump into the Azure Pipeline to take a look. All right, so my pipeline is here, and as you can see, my pipeline just kick off. It will take, I think it will take like 2 minutes, so I might put some pause here for you guys. All right, so my pipeline finished. It was successfully completed. I have the stages here. As I said, I have different stages, and if I go to release, which is the most important part, my tokens were replaced as I meant to be. I checked, but my application was completed. My Flyway migration was completed as well. So let's take a look at my jobs in Kubernetes, because that's the most important thing for now. So jumping back to the code here, let's take a look at the jobs from Kubernetes. I have only one job, is the migration number 100. So let's grab some additional information for my job. Let's take a look, and it says my job was successfully created and completed. No issues there. So let's take a look at what actually it did from the logs. So let me run this command to grab the logs, and it was a success. So my migration v1 of my application and database was created. My table structures, my constraints, and the data was loaded really quickly and easy. All right, if you want to make sure everything is there, I can connect to my cluster and run exactly the same query and check the objects. But the first way to do it is checking the website. So I have the website here, and let's take a look. Website is there. I can navigate. I can see the continents here, regions, and countries. So everything is good so far. Awesome. All right, so next step is to make some tags to make sure I am saying, all right, my version 1 is completed. So I'm going to add this tag in Kubernetes just to tag my deployment, and I can do it the same as well on GitHub. Something important is the configuration of my pipeline. My pipeline has certain configuration. I'm going to show you really quick here. And this configuration means I have enabled continuous integration for this pipeline. That means that any change happening in my master branch is going to kick off a new build of this pipeline. But we want to change that in future releases, because this was the version 1, but we don't want to do the same for version 2 and all over again. All right, so let's have our second demo of today. This demo is about the story of the version 2. So let me give you a context of what happened. After some talks with the developers and some of the end users, we figured out that the design we had for version 1 of our application wasn't that optimal for kids. So we decided to change the version of our application. And this second version has different things. We included flags, and the front end was completely redesigned. So let's take a look. All right. As I said, this is a new version, v2, so it's going to include flags of all countries available in the world. So we are adding a new column here to the countries table to have that flag. As well, we are loading the data and creating some views, because there was a conversation as well that some of the developers were using select star to retrieve data from the tables, and that's, as we all know, that's our practice. And also for abstraction and security, we put those views for abstraction and security purposes. So let's create a new branch on Git. So I have the v2 branch now. All right, now I am going to rename the original one to v1, and the v2 is going to be renamed or swap, and it's going to take the name of the previous one. Okay, so just rename the original, and let's rename the v2 to the original. Okay, cool, done. All right, now I am going to add my scripts from this v2 folder to my database SQL script folder for Flyway to use those new scripts. Okay, done. So this is my new Flyway migration structure. I have my previous migrations of v1 and these new 3 scripts that are part of the v2 version of my application and database. Okay, I am not going to take a look at the scripts for now. I am going to show you something important. Remember, I said that we have to configure the pipeline for continuous integration, but I disabled continuous integration because we don't want to trigger our main pipeline to build, test, and deploy any changes to a master, because that's not the best practice. The best practice is to create a new branch, in this case v2 for example, and I'm going to open a pull request with my changes to be merged into the master repository. So I changed the configuration of Azure Pipelines to say, okay, whenever there is a pull request, validate that pull request for master and build this new version of my application. So I'm going to add my changes, and I'm saying, okay, new application database schema version 2, cool, and let's push this v2 into my repository. All right, done. Let's take a look at GitHub now, and there we go. I have 2 branches, so I can start a pull request from here. So let me switch to the v2 here. All right, so I had a conflict that I just resolved, and I am going to commit merge, and here we go. My pull request has passed. All right, so my new build is in process right now. Let's see, the v2, and this is the date, and is in progress. So I guess I will pause this, and I will be back once this is done. Okay, so my pull request was successfully completed. My v2 of my application is ready. The release was completed. So let's go back to Visual Studio Code and let's figure out how the jobs are looking. So let's grab information about the jobs. So the job 102 was completed successfully. Let me grab some information from here really quick. And I will choose, I am just selecting the latest job here, and my latest job, it is in fact the 102, and let's figure out what was made by this job. All right, so in effect, the migration 2.1, 2.2, and 2.3 was successfully applied. Let's go to the application for a moment. Remember, this was not that pretty for kids, so let's take a look at V2. Oh, this is looking better, right? I can navigate here. These are little buttons. Let's take a look at the countries, and the countries should be loading the table, the flag. It took a little second, but I'm glad it worked. So great. Let's go back to Visual Studio Code. So once again, I can run some queries to grab the information from the schema history table, but this is pretty much what I am showing you guys here. Last thing I have to do here is just delete the branch that I created. And so let's check out to master. Let's delete the branch. Here we go. And I will delete the branch on at GitHub as well because I don't need it anymore. It was deleted, and I can create my new tag for my new version of my application. Let's go back here, and I will show you that I have one tag for the V1, so it will be just a matter to create a new tag here, and that's it. So we have an application created using a .NET Core and Flyway migrations. In case you have a question, of course, please ping me and I will be more than happy to help you. Right, so getting back to the presentation, this is a visual representation of what I did during the demos. Code changes were applied. I had this Azure Pipeline that pick up those changes. There were some automated processes that build, push, and test my images. Then I have this Kubernetes deployment that was split in two phases. The first one was about doing database migration using Flyway through a Kubernetes job. And then I simply apply my latest image of my application and perform a deployment to release my application to my end users. So let's have a review of today's session. DevOps and databases. We now understand the concept of applying changes for a database should be the same as working with an application, and we can approach this through database migrations using tools like Flyway, where we can integrate our database changes and application changes really easy through a pipeline created in Azure DevOps. And of course, we can use a platform like Kubernetes to support all those resources that will be changing and deploying constantly. Here are some references to Flyway's documentation, some books that I really think they are really interested and really focused on this topic, and also I include some Microsoft learning paths that you can use to get started with Azure DevOps, Azure SQL, Kubernetes, and some of the things that I talked today. If you want to take a look at more material about this topic, I have a few articles published on SQL Talk, on SQL Server Central. There is information in my blog, but the most important thing, if you want to download the demos of today, the slide deck, everything is already available on my GitHub repository. Please remember to fill out the session evaluation. This is really important to pass to make sure we speakers are delivering great content to you. Alright, so that's all for today. I really appreciate you attending this session. Have a great summit and thank you very much. Bye.